We are living through a moment in history when machines are beginning to understand us. Not perfectly, not completely, but enough to change everything. Tools that were once simple calculators or pattern matchers are becoming collaborators, thinkers, and in some cases, creators. But behind every smart response, behind every breathtaking AI breakthrough, behind every headline about models like GPT, Claude, and Gemini, is a staggering story of engineering, mathematics, data, human judgment, and intentional design. Today, we peel back the curtain on that story. This is how large language models, LLMs, are actually built. Every LLM starts with something surprisingly human: language. Billions of words, millions of documents, entire libraries, conversations, books, articles, scientific journals, code bases, all compressed into a universe of tokens. This raw material becomes the foundation of the model's intelligence. But it doesn't begin in some pristine state. It begins messy, ungoverned, chaotic. And before a model can learn anything at all, that chaos has to be transformed. It has to be cleaned, filtered, reshaped into something a machine can understand. It becomes a kind of neural fuel, the first spark of what will later feel like cognition. Once the data is prepared, the real work begins: building the model's architecture, the shape of the mind. Modern LLMs are based on the transformer, an invention that quietly rewrote the rules of machine intelligence. It introduced attention, the ability for a model to understand which parts of a sentence matter most, and then multi-head attention, multiple perspectives analyzing context at the same time. Almost like giving the machine several ways of seeing the world simultaneously. Architects decide how large this mind should be, how many layers, how many parameters, how far it can remember in a single sequence. Every choice is a trade-off. More power means more compute, more nuance means more data, more capability means more risk. This is where the soul of the model takes shape. Now comes the moment where the model wakes up. Training. Thousands of GPUs working in harmony, massive amounts of electricity, distributed systems tuned down to the microsecond. For weeks or months, the model performs the same task: predict the next token, again and again and again. From this strangely simple loop emerges something astonishing: language, reasoning, patterns, context, abstraction, knowledge. The model begins not just to memorize, but to generalize, to connect, to infer, to understand. This is where statistical prediction begins to feel like intelligence, but a raw model isn't ready for the world. It's powerful but unrefined, accurate but untrustworthy. So humans step in. Through reinforcement learning with human feedback, experts judge answers, rank results, give feedback, guide behavior. We sculpt the model, we align it with our values, we teach it how to speak to us safely, respectfully, coherently. Alignment turns a model from a machine that knows into a machine that can help. Before deployment, the model undergoes trials. Can it reason? Can it summarize? Can it write? Can it solve math? Does it hallucinate? Does it mislead? Does it hold hidden biases? Some models shine, some fail, all are revealing. Evaluation separates raw capability from real-world reliability. A trained LLM isn't useful until it meets the world. Deployment is where engineering gets practical, shrinking the model with quantization, speeding it up with caching, scaling it with inference clusters, embedding it into products. This is where AI stops being a research artifact and becomes a tool people depend on, from search to assistance to enterprise systems to creativity to education to science. LLMs become engines for ideas, accelerating work in every direction, but the most important part of an LLM's lifecycle is what comes after deployment. The model continues to evolve. It learns from user interactions, it improves through new data, it becomes safer through better alignment, it becomes smarter through updated architectures, it becomes more efficient through better hardware. The model is never finished, only becoming. This is the era of continuously evolving intelligence. Language models aren't magic. They're built, engineered, crafted through data, mathematics, computation, and human values, but what they enable, creativity, reasoning, discovery, feels like something entirely new. If you'd like more deep dives into AI, quantum computing, and the future of intelligent systems, subscribe and share your questions in the comments. And if your organization wants clarity, strategy, or support in navigating AI adoption, Mimico Design House can help. Thanks for watching, and welcome to the next chapter of intelligence.